first of 3 videos which are going to take us through the basic types of trig equations that we are required to solve in higher maths. So what do I mean when I say solve an equation? Well, let's think about what we've just been doing. We've just been doing exact value calculations. So on a sine graph, I might have asked you to find sine 150. That means I'm giving you an x coordinate of 150. And what am I saying? Sine 150 equals what? When the angle is 150, what is the related y coordinate? It's a half. So sine 150 equals a half. If we consider a cos graph and I'd asked you for cos 225, again I'm giving you an x coordinate and I'm asking you to find the related y coordinate. So if the angle is 225, the y coordinate is negative 1 over root 2. That's the process we've just been dealing with. When I say solve an equation, it's the other way around. So on this sine graph, rather than me giving you an x coordinate, I'm just going to say sine x equals, and I'm going to give you a y coordinate. And the y coordinate will be negative 4/5. So what is that asking us? So the question is really, which angles on a sine graph give me a value of negative 4/5? Well, we can see in one rotation between 0 and 360 there are 2 such angles, one in the third and one in the fourth quadrant. Now I'm pretty confident that most of you can solve a basic trig equation from National 5. I'm going to go through it graphically and then we'll go into our notes and we'll do it algebraically. So graphically it goes like this. In order to find the third and fourth quadrant solutions, we first of all find a solution in the first quadrant. And to do that, we ignore the negative on the 4/5. We just take a y coordinate of 4/5 and we ask ourselves, what is the first angle which gives me that y coordinate? To find that answer, we just type into the calculator the inverse sine of 4/5. And that tells us the answer is 53.13. So therefore the angle which first gives us a value of 4/5 is 53.13. I know therefore that the third and the fourth quadrant solutions are going to be related back to that angle. In the third quadrant, I'm going to do 180 add 53.13. So 233.13 is the first solution. And in the fourth quadrant, it will be 360 minus 53.13, and that'll be 306.87 degrees. Let's now go into our notes and do a quick recap of exactly how that should be laid out, because it's very important that we're consistent in this. We're going to do a quick wee recap from National 5 here. So this doesn't have a number in terms of your higher notes. We will just call this, we'll do a wee star. How do I do a star? A star, and say N5 recap basic trigonometric equations. Okay, so we need to make sure we're all doing this in the right and the same way before we move on to the next wee section. So we have to consolidate whatever your knowledge currently is and make sure that we get it all together. Okay, so this is just a wee recap topic. You should completely know this, but it might help to now hear it explained again in terms of what you know. So the way to solve basic trigonometric equations, and you'll see this in practice in a second, was firstly, we always isolate the trig term. So the trig term might be sin x or cos x or tan x. The second stage is to find the related angle. And thirdly, we use the quadrant diagram. Use quadrant diagram to find solutions. Okay, so those are the 3 things. I'm not going mad into the note here, I'm just going to go straight into an EG and just remind you of the way that a trig equation should be solved. Right, so EG, let's say we've got something like 5 sin x add 5 equals 1. And I have to state a domain. I have to tell you, do I only want you to consider the first rotation or do I want you to consider several rotations? Well, I'm going to tell you I only want you to go between 0 and 360. So it's only one rotation I want you to consider. I'll point this out to you. These should not both be included in a turn. You'll be given this in the question, but it'll be one or the other, because if I include both, then I've actually included 0 and 360. It's the same thing twice. So I'll include 0, but I won't include 360 in my domain here. Okay, so what values of x between 0 and 360 make this true? So what x's can I substitute in there that'll give me an answer of 1 is what the question's asking. Well, okay, first thing we do is we isolate the trig term. So let's move that add 5 to the other side, and the opposite of adding 5 is subtracting 5. 1 subtract 5 is negative 4. And then let's completely isolate that trig term. Then let's get sine x completely by itself. Well, to do that, we're going to divide the 5 down underneath. So negative 4 fifths. Right, so that's point 1 completed. We have isolated our trig term. Sine x equals negative 4 fifths. The next thing is find related angle. Okay, so I'm just going to write RA for related angle equals. Now, this is where we do inverse sine of 4 fifths. We don't put in negative 4 fifths because we're only interested in what the first quadrant angle is. So I'm not interested in where it's negative at the minute, I'm just interested in what actual related angle do I get, and it's 53.13 degrees. That's my related angle, that's my first quadrant solution. Now that might be one of the final solutions, but it might not be. So we can't write x equals yet, we just write related angle equals. Okay, now we go to our quadrant diagram. Like so. We fill in our all, sine, tan, cos, and we consider this. We want to know the values of x for which sine x is equal to negative 4 fifths. Well, I know that sine is positive in the first quadrant. In the second quadrant, sine is positive. But in the third and the fourth quadrant, sine is negative. So the only places I could possibly have a negative answer are in the third and fourth quadrants. So that's where my solutions will be. So finally, my x values are going to be 180 plus in this quadrant, so 180 plus that, which is 233.13 degrees, and then 360 minus that angle. So 360 minus that will give me 306.87 degrees. So the two angles for which that initial equation is true are 233.13 and 306.87, and that's how we solve a basic trigonometric equation. Okay, so the first little stepping stone into a higher maths equation is to consider a multiple angle. So we've just solved sine x is equal to negative 4 fifths. A multiple angle would be something like sine 2x equals negative 4 fifths. So 2x is called a multiple angle because I have multiplied the angle by something. Sine 2x really just means there are two cycles in a period of 360 degrees. So how's that affected our solutions? Well, you'll remember we previously had a pair of solutions, one in the third and one in the fourth quadrant. You'll now see that we have two pairs of solutions, meaning a total of 4 solutions to this equation. To get the first two, we can simply just half the previous two answers. But to get the second two, we have to consider what the period of the new wave is. And I'm now going to show you in your notes exactly how you should lay that out. Okay, let's move on then to the first higher maths skill, which is 4.3 multiple angle equations. Multiple angle equations. And you'll be pleased to know that the way we actually solve these algebraically is almost identical to the way we did it in National 5. There's just one wee extra bit to it. Okay, so just to give a general definition, a multiple angle equation is an equation which features and rather than trying to describe what it is, I'm just going to say which features, e.g. something like sine 2x or cos 5x, or tan 3x, dot, dot, dot. Okay, that is your multiple angle. X represents your angle and it's been multiplied by something. That's why it's called a multiple angle equation. Okay, so let's go into example 4.3a. And we'll solve one of them. Okay. Now, I'm in two minds here because I could just do this same example again and I could make that a 2x and then it matches what we've just talked about, but I don't see the merit in that because we're just going to be repeating ourselves. So I'm going to do something a wee bit different. Let's say example 4.3a is going to be solve 2 sine, let's say 4x, add root 3 equals 0. And we'll say for 0 is less than x is less than or equal to 360. So this time I'm going to include 360 and not 0, but it's the same meat, different gravy. Okay, so we're solving that equation for this. Solution. Right, I've picked this equation because I'm going to try and kill two birds with one stone here. You see what I mean when we come to it. Sorry about the sniffing, my hay fever is absolutely off the charts today. So, let's start, we'll go through our same process, right? We're going to isolate the trig term, find the related angle, use quadrant diagram to find solutions. We'll do all of that, and then I'll explain why this is slightly different. So, write down our equation. 2 sine 4x, add root 3, equals 0. We're going to isolate this trig term here, which means the plus root 3 will come over to the other side and we'll divide by 2. So I'm just going to do that in one go. So sine 4x, which is my trig term, will become negative root 3, and then the 2 will divide down underneath over 2. So it's minus root 3 over 2. So we've isolated the trig term. It's now find related angle. So my related angle for this will equal... Now, two ways you can do this. One of the ways is you can get your calculator, as we did before, and we can do sine to the minus 1 of root 3 over 2 without the negative and hit equals. Magic, and it will just come out and it'll tell you what the related angle is. Alternatively, this could very well be in the non-calculator paper. Sine 4x equals negative root 3 over 2, because root 3 over 2 you might recognise as being one of the exact values from before. So I'm going to refer you back to one of your exact value triangles, and I'm going to refer you back to the one which features a root 3 and a 2. And hopefully you know by now, 30 is up there, 60 is down here, that's the smaller side, the longest side is 2, so that side there is root 3. So to find the related angle here, I am saying which one of those would hold true for sine of something equals root 3 over 2? Well, if it was sine 30, saw katoa, opposite over hypotenuse, sine 30 is a half, so it's not 30, but sine 60, opposite over hypotenuse, is root 3 over 2. So my related angle for this is 60. And just to be clear with you, I don't care that that says 4x just now. I'm just considering this as one whole thing. Sine of what gives me root 3 over 2. My related angle is 60. Now, I take into account the 4x. So rather than going to my solutions here, for my quadrant diagram, I'm going to go to solutions for 4x equals, rather than just x equals. I'll put my quadrant diagram down here. And I am looking for the quadrants in which sine is negative. So sine would be positive here, it would be positive here, sine is negative in these two quadrants. So 180 add the related angle would go in here. 180 add 60 is 240. And 360 minus 60 is 300. Okay, so we're nearly done actually. The only thing we still have to do is consolidate this 4x, because that's not a valid solution. The solutions I want are for x, not for 4x. So if I know that 4x gives me 240, what does x give me? Well, obviously we have to divide by 4. 240 divided by 4 gives me 60 degrees. That's one solution. And 300 divided by 4, well, the way to divide by 4, we've talked about before, is half it again. Half it's 150, half it again is 75. Okay. Now, that should feel pretty good to there. You'll remember from the picture I showed you just a wee minute ago, though, that we should have 4 solutions. For a sine 4x, for a sine 4x, we're going to have 8 solutions. We will always have twice as many as this gives us. So that's my first pair of solutions. But for 4x, we write this. 4x implies that we've got 4 cycles of the graph. And for every cycle, we're going to have 2 solutions. So that means there's going to be 8 solutions. The period, so therefore the period of the graph, the period, will be 360 divided by 4. So if you weren't listening there, start listening. 4x, basically you do 360 divided by that, and that gives us 90. So that tells me that this pair of solutions will repeat every 90 degrees. 90, 90. So to get the rest of my solutions, I just add 90, and then I add 90 onto both of them, and I add 90 onto both of them, and I keep going until I've got a solution that's too big. So 60 add 90 gives me 150. 75 add 90 gives me 165. That's my next pair of solutions. 150 add 90 gives me 240. 165 add 90 gives me 255. 240 add 90 gives me 330. 255 add 90, am I still on the camera here? Yeah, just gives me 345. So far so good. 330 add 90 gives me 420. That's too big because my domain was between 0 and 360. So that gets crossed out, and I have 1, 2, 3, 4, 5, 6, 7, 8 solutions. So those are the final answers. Now you can write them out again horizontally if you want. I don't see any need to do it. I like to just do a wee double underline under the last valid ones. Like that. 420 was too big. So 1, 2, 3, 4, 5, 6, 7, 8 solutions for that is what we were looking for. You might say, do I have to do this? Well, certainly if we were in class you would be asking me that. Do I have to do this? And I would say, no, you don't. But it's quite nice to show that you knew that there are solutions which continue on forever, but you knew to stop there. So it's quite nice to show that. So those are the 8 solutions for this equation. Right, so I'm actually going to add in an example 4.3b, just to clarify exactly the reasons why you're doing what you're doing, and also to add a wee extra step in that we've not actually covered yet, and you'll see what that is very shortly. So example 4.3b is going to be quite similar. We'll do solve, I think we'll do a cos one this time, so we'll do 4 cos, and we'll do a 2x, subtract 2 equals 0. And we'll say for 0 is less than or equal to x is less than 2 pi. So hopefully you should see what the difference is here. It's that I've given you a domain which is clearly in radians. That means our final answers are going to be in radians. So as we go through this, it'll become clear what that actually means in practice. So the question is asking, which angles can I put in there which would make this equation true so that the final answers are in radians. Okay, so here we go. We follow exactly the same process. 4 cos 2x, subtract 2 equals 0. Isolate the trig term. I'll just do this in one go again. You don't have to do it in one go if you're not comfortable, and if you're going to make daft mistakes, don't do it in one go. Minus 2 is going to come over and become a positive 2, and then I'm going to divide by 4. So I'm going to get 2 over 4. 2 over 4 is the same as a half. If you think you're going to come back to your notes and you're not going to know where that came from, then write it out where that came from. We took the 2 over, we divided by 4, 2 over 4 is a half, is what I've done there. Okay, again, I can do this without a calculator, so I'm going to. And by the way, don't be lazy with this. If you think a question can be done without a calculator, then you should be doing it without a calculator. because it is going to become a part of what you're expected to be able to do. That's 30, that's 60. That's root 3, and that's 2. Okay, cos of what gives me a half? What's my related angle going to be? Cos of what gives me a half? Well, if I do cos of 30, that's adjacent over hypotenuse, that's not a half. If I do cos of 60, adjacent over hypotenuse, that is a half. So my related angle is 60. Okay, so my next line will be 2x equals, and I have to figure out where my two solutions are going to lie. And that means use my quadrant diagram. So I am looking for the quadrants in which cos is positive. It's positive in here, no, no, yes. It's positive in quadrant 1 and quadrant 4. In quadrant 1, we just use the related angle. In quadrant 4, we do 360 subtract the related angle, so 300. To bring that back down to just x equals, I divide both of those by 2. So 60 divided by 2 is 30, 300 divided by 2 is 150. Okay, so that's my first pair of solutions. Remember, when we've got a multiple angle, we have to go over here and say 2x implies 2 cycles. Therefore, the period will be what? It will be 360 divided by the number of cycles, so 180. So this time I'm adding 180 onto each of my solutions. 30 add 180 is 210 degrees. 150 add 180 is going to give me 330 degrees. 210 add 180 will give me 390 degrees. There's my child screaming. I hope that's not getting picked up on the microphone. Okay, so we have 1, 2, 3, 4 solutions. That one's invalid, it's too big. Okay, so in the first place, in degrees, those are my 4 solutions. But I'm not finished because this is in radians. So actually, my final answers are going to be as follows. 30 degrees in radians, I hope you remember, is pi divided by something. So pi is 180. So 180 divided by what gives me 30? 180 divided by what gives me 30? It's 180 divided by 6. And many times does 30 go into 150? You'll enjoy this bit. So 30 goes into 150 5 times. So that times 5 is the same as 5 times that. Okay, so that's 30, and that's just 5 30s, which is 150. 210, well that's just 7 times 30, so it's 7 of those. And 330 is 11 30s, so 11 pi over 6. Okay, so pi over 6, 5 pi over 6, 7 pi over 6 and 11 pi over 6. Those are our 4 solutions in radians.